Okay, our second last reduction formula, but the last one, it's kind of a given. So this one here, we're going to look at 360 minus. So let's get into it from the picture. So I think we need the picture to see what we're talking about when in the 360 minuses. So we started with a point in the first quadrant. Now, our first quadrant we had in this maroon, right? So let's stick to this. So we had a point over here that we said this point is sitting, we can call it P, and it's sitting at A, B. Now this time, last time we reflected into the second quadrant, then we're going into the third, so we just need to head into our fourth quadrant, right? So for this one, let's go pink again and say we're going down here. That doesn't look like a great reflection. And if this initial angle were theta going around there, well, this angle over here is also going to be theta because it's a reflection. The coordinates here. Remember, I said, well, can you imagine we had numbers? So this were 3, 4 sitting in the first quadrant, and R, we said, let's pretend that it's 5. Can be any value, but we're just showing it with real numbers. And yes, badum tush with the real numbers. So if this were 3, then this value here, its x value, would still be 3. It's still 3 across in the positive direction. So in other words, its x value would still be a. If that's 3, it's still 3. If it's a, it's still a. And on the y value, if this were 4 and it's been reflected, well, wouldn't this be at negative 4? So this value here would be, let's just get our colors right. So this we said was still a. If this were 4 and this were negative 4, instead of b, this would be negative b, and r stays the same. If r were 5 before, then r would still be 5. Okay, now angle we're interested in is getting to this line. So the angle is coming around here, and it's getting all the way there. So if this full revolution is how many degrees? 360. So a full revolution is 360. And we're not going that last theta, so this is just 360 minus theta. In other words, if this were 20, then this whole thing would be 340, because you just would have said 360 minus. I mean, we've been doing problems like that since grade 8, grade 9, yeah, but in a very different context now. So the trig ratios we're going to be interested in now are sine of 360 minus theta, cos of 360 minus theta, and tan of 360 minus theta. Okay, so those are 3 trig ratios that we're interested in now, and we're going to compare to see, are they just the same as sine theta, or is it going to be negative sine theta? Cast diagram to remember these reduction formulae. So C, A, S, T. Cast, I always start with the A actually, thinking A is top right. Okay, so cos is the positive one. So if that logic works, then we're going to say, well, sine of 360 minus theta is just the same as, well, it's going to be negative here, and it's going to be positive here, so it must be negative sine theta. Cos of 360 minus theta equals, well, cos is positive here and positive here, so I'm saying we just got to remember that those are the same, and tan of 360 minus theta is, well, tan was negative here, positive here, because only cos is positive in the fourth quadrant, so this is the same as negative tan of theta. And there your reduction formulae, done. But let's just check ourselves out here. And yes, I'm going through this more quickly because you've got the previous videos to get ourselves into this. And if you've been watching each one, you're like, yeah, I know. But I'm clicking pause so I can sketch it in time, right? And write down because I'm writing and speaking, but I'm expecting you to hit pause when you need to. Okay, so we've got sine of theta, cos of theta, tan of theta. Let's see what these are in terms of A and B and see how they match up with these. So sine theta, we've done this one a few times, right? It's y of r cos theta is x over r, and tan theta is y over x. Y over x. Okay, sine 360 minus theta. Well, that's now for this point over here. So this point down here, sine is y over r. So this one's negative b over r. Hey, look, it's the same as sine theta. It's just negative. That's what we said. This is the same, just negative. Cos of theta, a over r. Cos of 360 minus theta, well, it's x over r. Well, x is still a. So those two are the same. So cos of 360 minus theta is just cos of theta. And tan 360 minus, well, tan is y over x. So it's minus b over a. Hey, have a look at that. It's the same. It's just negative. So tan of 360 minus theta is minus tan theta. Let's choose one of those. Let's choose the tan one and check. So what I'm saying is that tan of, let's take, what do we want? 3, 1, 5. Right? How are we going to work that out? So we're going to say, well, this is the same as 360 minus 45. 315 is 360 minus 45. I think, is it? 360, lost my confidence for a second. 360 minus 45, 315. Cool, regain my confidence. And I know you might think, why is he keeps on going about this calculator thing? I think it's just nice. Now I've got my confidence. Yes, I'm definitely happy there. Okay, now tan of 360 minus an angle. From my reduction formulae, I'm saying, well, 360 minus theta is just negative tan of that angle. So in other words, 360 minus 45, it's tan of 45, but now I must take the negative of it. Okay, so it's negative, there's that negative. Tan of 45 we said was 1, so it's negative 1. But let's just check, doubting myself here. Tan 315. Yes! I'm like, yeah, I got that, right? I don't know, I'm being silly but honest as well. I think that is quite a nice feeling of, yes, I've shown all my steps here. Yes, the calculator confirms that I've got it right. The point of what we're doing here is not really, hey, you know how to work out what tan 315 is. It's minus 1. Yes, you got the right answer. This is the stuff that we're interested in. This logic that you're doing. This workflow that you're doing. These are the interesting bits in mathematics, not that happened to equal negative 1. I was going to say, who cares, it's negative 1. Maybe that's a bit too far. But what I care about is this logic, and you developing such a good sense here. That's what we're doing in mathematics. So it was negative 1. We've got no context for it. It didn't help us solve a problem. But we're developing such great logical workflows and reasoning here. So that for the 1. And that's our second last reduction formula. But the next one's kind of a given.